For this last example in section 4, we're going to look at a real-world problem. We have this roller coaster called the Magnum XL200, and it moves 41 feet upward for every 80 feet it moves horizontally. At the crest of the hill, you've moved 400 feet horizontally. So what we want to do is make a table first, and we're going to show the height of the Magnum at every 80 feet. So we're going to start out 80 feet, gives us 41 feet upward, and then the next one would be 160 feet, and we double this as well, so that would be 82, and we're going to do that until we hit 400 feet, and we'll find out what the height is at that point. And that's what they want here. The second part of this, we're going to write a fraction that represents the height the Magnum climbs for each foot it moves horizontally. If you notice, we're doing a rise, because it's the height here, over horizontal movement, which is the run. So it's really rise over run. The numerator here will represent the slope of that climb. And then for the third part of this, we're going to look at another roller coaster, Millennium Force, which climbs at a slope of 1. Now the horizontal distance this time is 310, and hopefully you know that if it has a slope of 1, it goes up 1 over 1, up 1 over 1. If it went up 2, it would go to the right 2. So therefore, if it goes to the right 310, it's also going to go up 310. So we're going to compare the slope of the Millennium Force to the Magnum XL, whatever it was called. Okay? So we look at this, and again, at 80 feet horizontally, it's at 41. At 160, it's at 82. Till we get to at 400 horizontally, it's at 205. And then what we want to do for the Magnum XL200, we know the height is 205 feet at 400 horizontally. We're going to find the slope, and again, remember that's rise over run. So the rise is the height, the run is the horizontal. We can use any of these. We could use 41 over 80, 82 over 160, 205 over 400. We'd get the same answer in either case. And if we do that, if we reduce this, just divide those and get a decimal answer. This top part represents the slope. So the slope is 0.5125. And finally, for the last part of this, we need to graph both of these. We know that it starts at 0, 0 and it ends at 400, 205. This one has 310 and 310. If you notice, the slope is steeper here. So therefore, since the slope is steeper, that means that this is a steeper slope. Yeah, basically. Okay, sorry about that. So the slope of the Millennium Force is more because it's 1 as opposed to the 0.5125. So 1 is greater than 0.5125. The Millennium Force has the steeper climb. And we're going to do this again. The answer is already there, but I'm going to do this real quick. We're going to look at the slope of Q, and what we do is we take the y's, so that would be 5 minus 0, and on the bottom it's negative 4 minus 0. That gives me a negative 5/4. And we're going to look at the slope of T, which again we take y2 minus y1, which is 7 minus 0, and then we do x2 minus x1, so negative 10 minus 0. We get a negative 7 over 10, and we can state that negative 5/4 is going to be steeper than negative 7/10 because 5/4 is greater than 7/10. So that it'll be going down quicker than this one will, because the positive versions 5/4 is bigger than 7/10. So line Q ends up being the steeper of the two. And finally, for this last one, we have another roller coaster where the slope is, it goes 300 feet upward for every 350 moved horizontally. So again, remember, slope is rise over run. So it would be 300 over 350. And if I use my calculator, I'm going to get approximately 0.85714. Now, if you remember, the magnum was 0.5125. The slope here was 1, so we can say that the slope of the new roller coaster is more steep than the magnum, but less steep than the millennial force. Again, more steep than the magnum, less steep than the millennial force. And that's it. Thanks.